Hello, this is Dr. James Camp, and this is another in the series of Camp C++ Quickies. Today we're going to talk about documenting your code and the importance of using certain ways of naming your variables and the idea of comments and things like that. Okay, so if you look at this program, if you read the cout statements, it's pretty obvious what we're trying to do. We're taking whole inches and 1/16 of an inch, and we're outputting the size in millimeters. So we're doing a unit conversion. But if you look at this formula here, if I just dropped that down in front of you, it wouldn't be obvious at all why these particular numbers were being used. Okay, unless you happen to recognize a couple of them. This is what in programming terms we refer to as a magic number. Okay, that is, it's a number that just gets dropped into the code, and later on when somebody comes to try to maintain this bit of code, they don't understand where that number came from. So imagine that instead of this just being a program that was doing a unit conversion, this was a program that was calculating the size of an entire piece of machinery, and so it had to run this function several times to convert inches into millimeters, but it never explained that that's what it was doing. It just kept running this particular calculation over and over again. And somebody who just came in to look at that code wouldn't necessarily recognize that 2.54 is how many centimeters there are in an inch. So there are a couple of ways we can make this code better documented, make it more readable. So one is that before a function, it's common to use a multi-line comment. And in the C family, multi-line comments start with /* and end with */. And many people put an extra star in front of each line. Okay, let's make it look cute. So this main function converts a fractional inch part size to a metric part size in millimeters. Inputs, user enters whole and fractional parts of an inch. Outputs, program displays the size in millimeters. Okay. So now somebody doesn't have to read my cout and cin statements to try to figure out what I'm doing here. I've actually told them ahead of time. Okay. So that's a use of a multi-line comment, and that's very handy. Another one here is if you look at my my number names, num1, num2, and num3 are, I didn't even use num3, so it would be num3 equals that. Okay. So your part is num3 millimeters in size. So that makes this line even more confusing because we don't see that we don't have the millimeters being output as part of that line. Okay. So we've got this, whatever num3 is, it's num1 plus num2 over 16 times this conversion factor. Okay. How could we make this easier? Well, you could make your code self-documenting by using sensible variable names. So if I change num1, okay, my rename, Control R, okay. If I change num1 everywhere where it is to whole inches, okay, okay, Control R isn't working, so I have to do Control R, Control R, okay. Okay, so I change num2 everywhere that it shows up to to 16th inches. Okay. And then num3, when I look at this, what I really want this to be is decimal millimeters. Okay. And when I do that, that actually makes it even more obvious that I made a coding error here, a logic error, that this should be a double. Okay. Because if I want it to be not whole or 16ths, but decimal millimeters, then it needs to be a double. Okay. So now when I read this line of code down here, decimal millimeters equals whole inches plus 16th inches over 16. Okay, well, so far, that makes sense, right? Times 2.54 times 10. Okay, if I didn't know my conversion factors, if I didn't have those memorized, that would be a problem. So another thing we can do to is replace some of these magic numbers with constants. And C++ gives us a const keyword. So I can say const double millimeters per inch equals, and I'm going to just go to Google real quick and say convert 1 centimeter to, or no, 1 inch to centimeters. That's 2.54, so that's the exact number. I did remember it correctly. Okay. That's centimeters per inch, 2.54. And then I can do const double millimeters per centimeter equals 10. Or if I wanted to convert 1 inch to millimeters, it's 25.4. I could, no need that I have to have two conversions in there, right? So I can say that's millimeters per inch. So I replace all of this with millimeters per inch. Okay. And now, if I look at this, I say, okay, whole inches plus 16th inches divided by 16, which makes sense for 16th inches. Okay. That gives me a total number of inches times millimeters per inch. So that's going to convert inches to millimeters. And that makes sense with my thing. Okay. We can also add a single line comment. Single line comments can go nicely at the end of lines. So integer number of whole inches integer number of sixteenths. Remember to divide by 16. Okay. So if I run this program, how many whole inches? Let's say my part is 1 5/16 inch. So 1 5/16 inch, that's a 33 millimeter metric socket. Okay. 33.3, so it's a little bit bigger than 33 millimeter. Okay. What if I wanted to go the other way? You can use this main function converts a metric part size in millimeters to a part size in fractions of an inch. Input, user enters millimeters, program displays whole and fractional inches. Okay. So let's say we want to keep 16th inches as the smallest we go. We'll ask how many millimeters. There's my decimal millimeters. Okay. Now what I can do is I can actually use these comments to help plan my code before I write the code. So this is something I sometimes do, and it improves the readability of my code later if I leave the sort of pseudo-code comments in behind. So step 1 is find number of whole inches. That's millimeters divided by millimeters per inch, and I have to truncate that. Okay, truncate means get rid of any partial, any fractional part. 2, find number of find decimal part. Okay, so I've got to get millimeters divided by millimeters per inch. What I've got to get is the remainder of that. Okay, what's left over? Okay, that'll give me the decimal part, and then 3 turn decimal part into sixteenths of an inch. So that means I take the answer from part 2 times 16, and I'm going to truncate that as well to make sure it's an integer. Well, actually, the No, that's not what I want. I don't want the remainder. What I want here is millimeters divided by millimeters per inch minus what I got in answer 1. Okay. So, what we're going to do here is we're going to say, okay, int answer 1 equals, and there is actually, if we go into, well, there is a trunc function, but I actually can just use, I can just cast it to an integer, int of decimal millimeters divided by millimeters per inch. Okay. Find decimal part. Okay. So double answer 2 equals, I could just copy this part here, decimal millimeter minus answer 1. Okay. And then int answer 3 equals, again, I'm going to just truncate it off as an integer of answer 2 times 16. Okay. Now again, these comments that I've just made are fantastic, but I could be more self-documenting if I said, well, what does this represent? Answer 1 is really whole inches. Okay. So this is going to be whole inches. This is going to be decimal part. Okay. And this is going to be 16th inches. So now when I read my code, whole inches is decimal millimeters over millimeters per inch, truncated to an integer. Decimal part is decimal millimeters over millimeters per inch minus whole inches. 16th inches is decimal part times 16. That's much easier to read than answer 1, answer 2, answer 3, right? And that also helps me construct my final output statement. Your part is whole inches and 16th inches, 16th, inches. Okay, so if I run this program, how many millimeters? Let's say 22. Your part is 0 and 13/16 inches because 22 is not a whole inch yet. Okay, let's say we have 30 millimeters, 1 and 2/16 inches. Okay, so that's my motivation for why and how to use constants instead of magic numbers, why and how to use big, long variable names that are very descriptive, self-documenting variable names, and how to use comments both to explain the function of your code to other people and also as a way of planning out your code yourself as sort of a pseudo-code that you then turn into real code. Okay. That's it for this episode of Camp C++ Quickies. I hope you enjoyed it, and we'll talk to you more later.